Alright, so welcome. Today we'll be talking about Newton's method, which is just basically approximating roots. Okay, and actually this is really cool because what you're going to be doing is this formula right here is an iteration, and you're going to be approximating the tangent line, getting closer and closer to the number each time. Alright, so remember this is an iteration formula, and you will stop when you repeat the number. The first time, okay? All right, and the formula, for some reason, writing sub-ends and everything, can't do it on a regular keyboard, so I just write the next x is equal to the x before minus the function when you plug in x divided by the derivative of the function, okay? And when you plug in everything. Okay, so let's say that we take, let's mess with one. Let's go x squared minus 7, and we're looking at the point or the interval between, what is it, 2 and 3. Okay? All right? So, first thing we're going to do is find the actual derivative. So it's going to be f prime of x is going to be equal to 2x, okay, and then we start writing it out. So the next x is going to be equal to the x before. All right, minus, and then on top we're going to have x squared minus 7, okay, and it's going to be all over. And if we actually take a look at the graph, okay, if we take a look at the actual graph, we can see that the actual graph crosses between 2 and 3, or 2 and 3, but it actually crosses really close to 2.6. So if I had to guess, I would probably guess 2.65-ish? Yeah, 2.65. All right. So 2.65 is the first point I'm going to check out. So the next x, and what I'm doing is I'm actually doing an iteration. So I'm going to be plugging in 2.65 minus parentheses 2.65 squared minus 7 divided, let's go division. And so what I'm doing is I'm actually going to do this a couple of times to actually get a closer and closer answer to it, okay? And this is going to be 2 times 2.65, all right? Then I actually do it. Now, the first time you do it, you're not going to get the exact answer, but you are going to get really close, okay? And so we actually do it on Desmond. All right, and we find out the next x we are going to test is going to be 2.6458. Okay, you might want to go out to the fourth decimal place. All right, so, 26. Geez Louise. Look at that. I typed in a 3 instead of a 6. Okay. Now, we had the benefit of using a graphing calculator to kind of get us closer, just to show you how this all begins. Back in the day when they were approximating these decimals and everything, they did not have the benefit, so they just did the intervals of 2 to 3 and just worked with it that way. Okay? All right, so the next number we're going to use is this one. So in the next formula, we're going to be using the next x is going to be equal to 2.6458 minus parentheses 2.6458 squared minus 7 all over, oops, nope, I went the black line, there we go, over parentheses 2 times 2.6458 times 2, okay, and then we test that out again, all right, and we get the next x to be 2.65 4, 5, 8, which is pretty much the same as what we had before. Okay, so now if you notice, in 2 successive times we've had the one before, which remember that stands for the x before. Okay, and then the next x is going to be 2.645. So that's going to be the actual approximation. So the actual root of this is going to be positive 2.6458. That's going to be an approximation. So the really cool thing is that you're actually able to get the approximations using Newton's method by following this formula. Now, don't ever get confused by the iterations and how you do it. Just remember that the number you got before goes into here, and the next answer comes out of here. And then that will go into right here, and then this number will go right there, and then this number will go right there. Oh, sorry. This one will go right there, and then this one will go right there. And it's a continual cycle of just iteration. Okay, so that is it for Newton's method. If you have any questions, please feel free to ask. Just remember, find the derivative first, put it in the denominator, put the function up here, and then start plugging in x's and start looking for numbers. And you could start with 2 and 3. Just don't do 1 and 4 and just mess with that, because it's going to take a lot longer. Okay, all right, you guys have a wonderful day, and I'll talk to you later. Bye.